Accelerated Chemistry students. This is Ms. Crisafoli, and this is your Chapter 11, Section 2 notes all over types of chemical reactions. So there are basically 5 main types of chemical reactions: synthesis, decomposition, combustion, single replacement, and double replacement. And what we're going to do in this video is we're going to go through each type, what the basic chemical equation for them looks like, and then in class, we're going to be doing a lab activity where you're going to be using your knowledge of the different types to figure out which type of reaction you're actually performing. So, not all chemical reactions fit uniquely into one category. So occasionally, a reaction may fit equally well into 2 categories. Patterns of chemical behavior will become apparent and allow you to predict the products of the reactions. So let's look at synthesis. Synthesis occurs when 2 or more substances combine to form a new compound. So your basic formula looks like A plus X makes a compound AX. 9 times out of 10, synthesis reactions are going to be 2 elements coming together to make a compound, like we have in our example. Lithium plus selenium makes lithium selenide. Decomposition is a reaction that occurs when a single compound produces 2 or more simpler substances. So for a decomposition reaction, it is actually the reverse of a synthesis. So you'll start off with a compound AX, and then you'll break it up into its elements A plus X. So our example is HGO, and that's going to break up into Hg plus O2. Combustion reactions occur when a substance combines with oxygen, releasing a large amount of energy in the form of light and heat. So reactive elements will combine with oxygen. So phosphorus will combine with oxygen to make tetraphosphorus pentaoxide. Or you can burn a carbon-hydrogen compound. A carbon-hydrogen compound is just that. It's a compound that has carbon and hydrogen in it. So propane is a good example of that. So we have propane burning in the presence of oxygen to make carbon dioxide and water. A single replacement reaction is the replacement of either a metal by another metal, hydrogen and water by a metal, hydrogen and an acid by a metal, or a halogen by a more active halogen. So here are the 2 skeletal equations that you can see. So you could have A plus BX gives you AX plus B, or Bx plus y gives you By plus x. In order for metals to replace other metals, they need to be on the activity series, and that's our chart that we use to determine whether or not the metals are going to replace each other or not. So metals above hydrogen can replace hydrogen and acids, and metals from sodium and up can replace hydrogen and water. So basically what you need to figure out is you need to look and see where are the elements that are going to be switching placed on this activity series. If the element that you are replacing is above, it's going to swap out. So what does that mean? Let's look at an example. So Na and KCl. So Na and K are going to be our metals in this scenario that are going to switch places. So we need to figure out where they are on the periodic table or on the activity series. So Na is located right here and K is up here. So no reaction is going to occur because K is more reactive than Na is. Now let's look at this example. Manganese and iron 3 oxide. So manganese is down here and iron is below. So this reaction will occur. Our manganese and our iron will switch places. And the reason why they're going to switch places is because manganese is a more active metal. And so it will switch places with iron. This is going to take a lot of practice. Don't worry, we're going to do it in class to figure out whether or not these reactions will go or not. Now let's look at the non-metals. So let's look at our halogens: fluorine, chlorine, bromine, and iodine. So again, metals can replace other metals provided that they are above the metal they're trying to replace in the activity series. Okay, so metals above hydrogen and then metals above sodium. But for this case, we're going to be looking at our non-metals. So let's look at this. So we have NaCl and F. So F and Cl are going to be the ones that are going to replace. Cl's right here, F is above it, so F is more reactive, and it is the one that is replacing chlorine, so that reaction will happen, and we'll get sodium fluoride and chlorine gas. Let's look at one more example. Magnesium chloride reacting with bromine. So we have chlorine is right there, bromine's beneath it, so this reaction will not happen. And there are going to be times where we're going to be writing chemical equations in class where you're going to have to know this, because you're going to have to recognize that sometimes a reaction doesn't happen, sometimes a reaction does happen. And how do you determine when it happens and when it does happen? Things like this will allow for you to determine that, as well as what you're going to learn about in section 3 of this chapter. So now let's look at the last one, double replacement reactions. Double replacement reactions occur when ions of two compounds exchange places in an aqueous solution to form two new compounds. So you can think of this as two couples switching partners. So AX plus BY gives you AY plus BX. The key for us to determine whether or not a double replacement reaction has happened is usually a precipitate or a solid forms, an insoluble gas will be formed, or a molecular compound, which is usually water, also is made. And that is the end of our video notes. And as always, all the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition of the textbooks, resources CD, and pearsonchem.com. Thank you so much. Have a good night.